Um, okay. You can see the screen.
Yes, I can see the screen.
Okay, so it says question 4. A wooden box slide down a rough 8-meter long incline plane, which is AB. The initial velocity of the box at A is 2 meters per second, as shown in a diagram below. Now, they want us to define, what is it again? A conservative force. I want us to define what is a conservative force. Okay, now when we talk about the conservative force, we are talking about the force for which the work that is done, it is independent of the path taken. Right, let me add a page so that I write it down. So that is 4.1. So for 4.1, so what is it again? A conservative force. Okay.
Yes.
So when we talk about a conservative force, it is a force for which work done on the object is independent of the path taken. So, for example, we are talking about work done by force of gravity. Okay, force of gravity doesn't matter where you are; it will always remain the same. So they want us to name the non-conservative force that's gonna take place here. Of course, when it slides down, it is going to fall due to gravity. So
Yes.
the force applicable there, it is going to be force of gravity. Oops, this table makes a lot of noise. Okay, now let's check again. State
Are there
the
any other types of conservative forces or friction
yes.
force under non-conservative?
Under a conservative or non-conservative, which one do you want?
Okay, let's stick to conservative.
Okay, it's fine. I can give you both, by the way, right? So that
Okay.
you are on the safe side. So, for conservative forces, let me write with a different color. For conservative force, we are talking about Fg, force of gravity. We are going to talk about the spring force. What else? The spring force and electrostatic forces. Okay. So Fe for electrostatic force. So these forces, they are forces of attraction. Only F of the spring, it is the force of repulsion. And they're independent of the path they take. Right?
Okay.
So a spring is a spring. It can hit you with a painful force at any given terrain. It is not dependent on the path. Then, whereas the non-conservative force are forces like tension, applied force, kinetic frictional force, engine force of the engine, and so forth. Those ones they are non-conservative.
So it's tension, friction, and
Force applied.
okay.
Those are examples of them. So these ones they are non-conservative, and then these ones in blue they are conservative. hope the black ink won't disturb you when I send you the PDF. Right?
Okay.
Fine. Are you okay?
Yes, I'm okay.
No problem. Now, 4.3, they want us to state the work energy theorem in words. State the work energy theorem in words. Okay, so the work energy theorem in words states like the net work done, the net work done on an object the net work done on an object, okay, by the net force is equal to the change in kinetic energy of the object. Okay, so that is the definition. The following is not required, but I mean, you can just write it. The formula is W net is equals to change in EK. So you can use this formula in case you forgot the definition. You can go back and look at your formula. So W net equals to change in EK and put it nicely in words. W net, the net work done on an object, equals to, by net force is equals to, and this is the change in kinetic energy. The change in kinetic energy. So the only additional weights are the object on the object. Other than that, the formula gives you the definition. Can you see the relationship?
Yes, I can see.
Okay. Question 4.4. The velocity of the object of the block at point B. So here, the velocity, so V final equals to 6.92 meters per second. When I write V final, it is with relative to point AB. So meaning A will be initial, point B will be final. Okay.
Final, like before and after.
Okay. Now, use energy principles only. There's a reason why they write it in capital letters. Other formulas work, right? Like equations of motions, but they don't want them here. They are not assessing that. Okay? So use energy principles only to calculate the frictional force that the block experiences as it moves from point A to point B. Okay. Use energy principles. So they are very specific. They didn't say we must use work energy theorem. They said we must use energy principles. So meaning that any formula that falls under work energy and power. Okay. So therefore, I'm going to make use of the formula W work done by non-conservative forces. Okay. Let me write with a black pen. Work done by NC. It means work done by non-conservative forces is equals to what? The change in kinetic energy plus the change in gravitational potential energy. Okay, this formula is given to you on your formula sheet. Okay, so what is the non-conservative force that acts on the object? So if we go there, because it said work done by NC, the non-conservative force that I can see, it is frictional force. There is no tension, there's no force applied. The only forces here, it is G parallel, which is conservative, and kinetic frictional force, right? So G, it is a conservative force. So there's no way we can put force of gravity or G parallel in WNC because it is a conservative force, not a non-conservative force.
Okay.
Is it clear?
Yes, it's clear.
Okay. Are you speaking Sepedi or Sezulu?
Both.
Nkosi yami. Kopas. Okay. I wish to be you. Okay. Now, so work done by NC, that will be the work done by the kinetic frictional force. So it's going to be Fk multiplied by the change in x. Change in x, it is displacement, where the force is applied over, and then also multiplied by the direction, so the cosine of. So now, because of we are dealing with kinetic frictional force, so it is going to be the cosine of 180 degrees.
Okay.
Why? Because the kinetic frictional force always acts opposite to the direction of motion. Always.
Hey, Chief!
Yeah, man. Blanca, you're back, man. I'll talk to you after the class. Sure. So the kinetic frictional force always acts in the opposite direction of displacement. That's why it is the cosine of 180. Cosine of 180 degrees is minus 1. So it simply means in the opposite direction. When they are going to the same direction, we use 0. So why is it 180 and 0? If the object is going there and the force is going to the opposite direction, the angle in between them is 180 degrees, a straight line. But if the object is going there and the force is also going there, the angle in between the two forces is 0. So that's why we put the cosine of 0.
Okay.
Fine, you're fine with that.
Yeah, I'm fine with that.
Okay. Now, the change in kinetic energy, it is half. It's gonna be half 1/2. I'm just gonna put them in brackets so that you can differentiate between changing K and changing UP. So it's gonna be half mass times V final squared, and then minus, because it's changed, it has to be minus half mass V initial squared, then plus, this is the plus from the formula, then the one from potential energy, it's mgh. So this is mgh, this is the final, so the final at B minus mgh at A. Okay. Now we substitute values. Right? So now let us go back to the diagram so that we can substitute our values. Okay. Let me see. Okay. Delta x is 8 meters. Delta x is 8 meter. And then the final velocity here, I can see it is 6,92, right? Now, the initial velocity of the box is 2, right? So they give me initial velocity to be 2, the final velocity to be there. Okay. So now I think I've got enough information. So obviously, when we deal with the height, the final one is 0 because it is at the ground. But the initial height, we don't know it. Okay, what did they give it to us?
The initial height.
The initial height, agree, this thing makes a right angle here, like this. So it's going to be the sine opposite of my hypotenuse. So the height, so basically it's sine 30 equals to opposite, which is height, divided by hypotenuse, which is 8. So therefore h is equals to 8 sine 30. So we are going to replace the h with 8 sine 30. You are happy with that convention, right? Don't be surprised when I put it in the substitution. Okay, then we go down, then we substitute. So the question wants us to calculate, I think, kinetic frictional force. So it is our unknown. So therefore, Fk equals to, the displacement is 8, we saw it, right? Times -1 from cosine of 180 equals to, then we substitute. Here we've got V final, so it's mass. What was the mass now? I also forgot. 2 grams, 2 kilograms. 2 kilograms, okay. So mass is 2. Then multiplied by the final. Final is 6,92, right?
Yes.
Squared. Then minus 1/2 into 2. Initial velocity is 2, right? Plus the final height is 0 minus the initial height, so it's the mass of 2. The mass of 2 times g, which is 9,8, times the height. We got our height to be 8 sine 30 up there. Okay, then now we press everything on the right hand side on a calculator. So basically we have -8 Fk equals to, so if we press everything, it's half 1/2 times 2 times 6,92 squared, okay, minus 1/2 times 2, okay, plus, okay, minus 2 times 9,8 times 8 sine 30. Okay, I got -30. What is the value that we got? I got -32,51 something there. How much did you get?
I'm still pressing it here. Did you do the whole thing, or did you just did you separate the pluses?
I put it as it is, all of it. I just didn't put the 0, of course. But,
okay. Do we have to substitute the 2 and the 9,8, or can I just put 0?
where?
Where there's 0 for
No,
the.
just put 0. 0 is fine.
Okay.
Don't give yourself too much work.
Oh, it's minus. I got a positive answer.
You got positive value.
No, I just realized that it's minus 2 times 9.8. I put the plus instead.
Okay,
So,
okay. I will give you a chance because I want you to understand what I'm doing. Okay. So just place it for yourself on that side. I've already divided already on my side, but I want you to press.
okay. I got negative 35.11.
Negative.
35.
Yo. It seems like I'm the one who don't press fine. Okay. Let me do it again on my side, right?
I'll also try it again.
Times 2 into 6.92 squared minus. Ooh, fuck. No, sorry. There's not a squared here. Is it? Mass times. There's a squared here. I forgot the squared. Okay. I got minus 34. Everything else is the same. So here it is minus 34.
Okay, I'm still pressing it in. Okay. Okay, I also got minus 34.5.
Okay. Then we can divide by minus 8 both sides. We can divide by minus 8 both sides. So Fk equals to 4,31 newtons.
Yes.
Okay, great.
And then do we add direction over here or
Come again?
do we add direction like to the left towards this
Okay.
or
Yeah, you can say up the slope, maybe. Up the slope. Or to the left, it's fine. Or towards point A. The direction. To the direction of point A. Anything to those lines, it will work. They are strict about direction in momentum, not in work, but just
okay.
practice to put it there always.
Okay.
Okay. Question. What's the question again? Okay. Now, 4.5. They want us to calculate the coefficient of friction for the last horizontal stretch after point B is. So they are telling us that after the box passes point B, the coefficient of kinetic friction is 0.35. Okay, so this is mu k. Now, calculate the distance the block will travel before coming to a complete stop without using equations of motion. Okay, I'm gonna use W net because it uses change in kinetic energy, which has velocity in its formula. Right. So that is my reasoning of using it because the formula itself has something relating to velocity. So it's gonna make sense for me to check where it comes to a complete stop using that one. Okay, just give me a minute. I'm changing my my sitting position. The sign is dealing with me here. Okay. Therefore, 4.5. Question 4.5. Okay, therefore I'm going to use the formula W net equals to the change in kinetic energy, EK. Now, therefore, this means that we're gonna have F net delta x, the cosine of theta, equals to half mass times velocity final squared, then minus half velocity initial squared. Then we can now substitute the values. The intention is to get what?
The distance.
The intention is calculate the distance. The intention is to get the distance, right? Yeah, the intention is to calculate the distance. So now the net force when the block, remember, it's like this, then it becomes flat, right? Then it becomes flat. It's fine. So when the block is here, then it's moving in that direction. The only force that acts on it is the opposing force, which is F of kinetic friction, nothing else. So net force is the same as Fk. So Fk, we got it here to be 4,31. We got it here to be 4,31. Okay, so we got it there. But now, is it necessary here? That's the question. Is it the same as the Fk that comes down? The answer is no. Why? Because there's a new coefficient. So what is the plan? Now the plan is to break down F net into Fk. But what is Fk? So Fk can be written as mu k times the normal force, right? Mu k times the normal force, and then mu k times the normal force. Mu k times the normal force. What about distance? It says calculate the distance. Oh, the distance is our unknown.
Yes, the distance is the unknown.
Okay, so therefore I'm gonna leave it as our delta x. Delta x, then cosine of theta is equals to 1 over 2 mass v squared f minus 1 over 2. You are not forced to write a formula so many times. Only one of these gives you a mark. I'm just breaking it down so that you can see my patterns of where I'm going. Okay, you are not forced. Now I'm substituting 0,35, right? Times, what is the normal? Normal, it's mass times 9,8. So mass of the box is 2 times 9,8, right? So delta x, we don't know it, but it is we know if it's friction, it is the cosine of 1/8. So I'm gonna put delta x here because we don't know it. Equals to, now half, the final velocity is 0 because it stops, right? So it's 0 minus 1 over 2 mass, which is 2, and then the initial velocity, it is the final velocity of the P4, which is 6,92 squared. So the initial velocity in this case, when it goes flat, it is the final velocity when it came down. Okay, no problem. Now I think I have substituted now. So my aim is to isolate delta x. Therefore, my delta x will be equals to minus 1 over 2 into 2, 6.92 squared divided by 0.35 times 2 times 9.8, the cosine of 180. Now I'm going to place it on my calculator. 0.5, oh, there's a negative. Negative 0.5 times 2 times 6.92 squared divided by 0.35 times 2 times 9.8 cosine of 180. So I got my delta x as 6.98 meters.
Okay, I'm still
So,
calculating.
okay.
I'm not getting it. Let me try again.
Okay, no problem. Don't forget the squared.
Oh, yeah. Okay. Is the half not supposed to be negative?
It is negative.
Oh, it is.
Look at this.
Okay. Six. Eight squared divided. Oh, I wasn't adding the normal. Yes.
You got the same value?
Yeah.
Okay, great. No problem. Okay. This is 4.5, right? That was a question from work. Now, I want us to do an electricity question. All right. I wanted to give you another question for work, but it seems like we pushed a lot of time into this. So I want to
Okay.
add an electricity question. Just give me a second. Okay, I'm going to give you maybe 2 minutes or three just to read the question so that when I solve, you can move along with me, right, as I'm reading and solving. Okay, just read and understand the situation in a second.
Okay. Okay. Okay, I've read through the question.
Okay. Let's see now. Uh, in the circuit below, the battery has an EMF of 12 volts and an internal resistance of 0.6 ohms. Okay. The heater has a resistance of 10 ohm and the fixed resistor has a resistance of 30 ohm. Okay. The variable resistor R can change between 0 and 5 ohms. Okay. The variable resistor R is set at a resistance of 3.5 ohms. Calculate the total resistance of the circuit, including the battery. Okay. Calculate the total resistance of the circuit, including the battery. Okay. So there are three stages. It's this and that. This is the external circuit. Then plus that from the internal circuit. So I'm just going to add a page here. So it's 7.1.1. Question 7.1.1. So I'm going to start with a parallel connection, right? So how many are there? It is two resistors. So therefore, I will say 1 over R parallel equals to 1 over R1 plus 1 over R2. Okay? So, and then the total resistances is 10 and 30. So therefore, 1 over R parallel is equals to 1 over 10 plus 1 over 30. So this, if we add them together, this times 3 and 3, okay, let me just add them in a calculator. 1 of 10 plus 1 of 30. So I get 1 over R parallel to give me 2 over 15. So then I'm going to invert the two fractions just to find R parallel. R parallel, which will be 15 over 2, which is the same as 7.5 ohms. Okay, this is just the parallel resistance. It's not the overall resistance of a circuit. So now the combination of this is giving us 7.5 ohms. Okay. Now then they told us that the R is set to be 3.5. So this is 3.5. And then the other one is 0.6. So therefore, R total will be the 7.5 plus the 3.5 plus the internal resistance of 0.6. So it's 7.5 plus 3.5, which is 11, then plus 0.6, so it is 11.06 ohms. No, not 06, but 6.
Yeah, 0.6.
Ish. Okay. Yeah. Okay, it's something like this. Any question, or you are fine with everything I did?
No, I understand. Yeah, I understand.
Now 7.1.2, calculate the current that is measured by ammeter A2. Give me a second. Calculate the current measured by ammeter A2. So basically, from the battery, the current will travel like this. When it reaches this point, the current splits. So we are interested in only this current, only that current, right? So why am I saying that? Yeah, it is important for you to understand that it splits, okay? So now calculate the total current of the circuit, including the battery. So we've got the EMF, we've got the external and the internal circuit. So therefore, we can use that equation that they give us. It's the famous one in grade 12. Oops, it's 7.1.2, right? So that says EMF is equals to I into R plus R, like that, right? So therefore I will be the EMF into R plus R. So this is I total, by the way. So which is 24 divided by the total resistance, 11.6. So 24 over 11.6. So I will get 2.069 amperes. Okay. Now, from this point, we know the total current of the circuit, and then the question wants the current through A2, right? The question wants the current through A2. So now we are going to use ratios. Looking at the circuit, the current that flows to 10 ohms, so it will be total current. So IA2, it will be I total multiplied by, because of it's going towards the 10, we use the 30. So 30 divided by 30 plus 10, which is 40. So this ensures that the majority of the current goes to the smallest resistor. That's why we do the vice versa thing. So therefore, A2, we already got it to be 206. Sorry. So current through A2, A2 will be equals to 2.069 multiplied by 30 divided by 40 equals 2. So multiplied by 30 over 40. So I got 1,5 5 amperes. I got 1,55 amperes.
Okay, I got the same answer.
Okay, no problem.
Can you please go back up to the diagram? I just want to see that.
Okay.
Okay, can you please explain this again? The IA2 is equals to IT times 30 over
Okay.
40.
Okay. Now, don't be scared to ask again. Okay. So now, let me explain what is the job of a resistor basically. It is very good at its job. Its job is to resist the flow of current.
Okay.
Is to prevent the flow of current. So the bigger the resistance, the smaller the current that is going to pass. Okay. So now current, it travels from the positive terminal of the battery. It's gonna move like this. But when current reaches this intersection, there's two ways. So current will divide itself. Some of the current will go there, while some of the current will go there. Right? How does it divide? It divides itself based on the size of these resistors. Because this resistor is small, there is small resistance, meaning more current can flow because there's small resistance. More of the current can flow. Because of there's a huge resistance, only smaller current would flow there. Okay. So now, for us to ensure that that is true, when current goes to that side, it is influenced by this resistor. This resistance scared that current away so that it doesn't go through this path, and as a result, it went through that path. So therefore, if we want the current that goes through that path, we will use the same logic and say the current that passes through this, it is the current that was being sent by that. Okay. So therefore, I that passes through the A2 equals to from the total current, where the 30 sent by this divided by the total resistance of the two when you add them.
Okay, so you added them to get the 40.
Yes. Yes.
Okay.
Okay. So that is the logic behind me giving you this, right? And by the way, I nearly forgot. Because of this, this is Gauteng 2022 prelim. Just in case you'll want to see the memo after. Gauteng. So you look at this number, it will tell you the year. Okay. So Gauteng 2022. Okay. Paper one. So yeah.
Okay, so we're always gonna take the biggest resistor and then divide it by the total.
Yes. In parallel connection, you always take the opposite resistor and divide it by the total. And then in the case that there is multiple resistances, because it's not like sometimes it's going to be only two. But in your case, there will be two.
Yeah.
But just in case there's multiple resistance, another one is there. So what you're going to do, let's say there's another 10 there. Meaning the total is how much? It's 50. Right? In the parallel connection. So that means that you still here, you're no longer going to use 30, but you're going to use 40 divided by 50. 40 over 50 because you have added 10 there.
Okay.
Okay. All right. I think I've said enough. Now,
Yeah.
let's move and see. 7.2. The variable resistor is now adjusted to have a higher resistance value. How will this affect the power dissipated by the heater? Red only increases, decreases, or remains the same. And explaining your answer by making the use of a suitable equation. So I want you to substantiate. Basically.
Okay.
Okay. Because there is a higher resistance, it means that power must decrease. Because there's a formula that we need to keep in mind that says power equals to V squared over R. So if you increase the resistance, the power will go down. They're inversely proportional. So the
Okay.
answer will be decrease.
Okay.
Okay, so yeah,
So how
that
would
will
we,
be
would you
yes.
say obviously, how would we explain it?
Okay, all right. That's a nice question. So you are going to see so increasing resistance R or increasing R will increase, obviously will increase the total resistance of the circuit. Okay. So since it increases the total resistance of the circuit, it will hence reduce the total current can reduce the total current flowing in the circuit. So since there will be less current flowing, therefore there will be less power.
Okay.
Therefore there will be less power. And it's not only that formula, there's another formula that says P equals to VI that has nothing to do with resistance. So, but since increasing R decreases I, if I go down, P goes up, or if P goes down, I, so they are inversely proportional also. So can you see that it is always true?
Okay. Yes.
All right. Okay, that was the last of that. Question. This is a question in a practical format. You will do it as a homework. It will just test your reasoning.
Okay.
Okay. We so that we keep to your time. We will
All right.
swap to paper two. I'm just going to give you a 5 minutes break so that your brain takes a break. I need you fresh. So
Okay.
yeah, just a mini 5 minutes break. Then we can get to it again. So quarter past, we continue.
Okay.
I'm going to the bathroom. I'll be back now. Now, you can just familiarize yourself with the question. But
Okay.
it's a break. You don't have to, just in case you want to. You don't have to.
Okay.
It's a break. Yeah. Aha. Yes. Are you ready to to battle? Sorry, to battle chemistry now?
Yes.
Okay. Um. Now we are asked to define the term an acid based on Arrhenius theory. Remember, we've got an Arrhenius theory. We also have got what we call Lorry-Bronsted. Okay, so you need to know both of them, right? So for the purpose of this is a lesson, I'm going to answer the Arrhenius theory, but also give you the Lorry-Bronsted, just in case you forgot it. Okay. Okay, back running. Okay. 7.1. According to Arrhenius theory, an acid is a substance that will produce what we call hydronium ions when they're dissolved in water or in aqueous solution. Okay. So we're going to say an acid. Oops, nope. An acid is a substance that produces hydronium ions. Hydronium ions. Hydronium ions, it's H3O. Yes. When the acid, when dissolved in water, that is the Arrhenius theory, right? But because I want you to learn, we are going to also do the Lorry-Bronsted. But the Lorry-Bronsted theory says the acid is a proton donor. Okay, proton donor. Now, ouch.
Listen. Listen.
I'm sorry, I had to blow my nose.
It's okay.
Okay, yes. So those are the two different definitions that you need to know of an acid. Now, the Arrhenius theory is only limited to in water. That's why it is widely rejected. Okay. Now, 7.2, they want us to consider the following reactions. The reaction X and reaction Y. Now, from reactions X and Y, identify the reaction that illustrates the Arrhenius theory. So remember I said Arrhenius theory happens where? In water. Which one of the two have water molecules is reaction X. So because of that, we are going to base, we are going to answer with respect to X. So the answer will be reaction X. Reaction X. If you're 15 minutes, get all that headset. Okay, now let me see. From reactions X and Y, identify the reaction that illustrates, 7.2.2, write down a balanced equation for the hydrolysis of NH plus ions. Okay. So the hydrolysis, it is a reaction, it is more like a reaction with water, right? So now we need to take the NH plus ion. So that is 7.1.2. So hydrolysis, it is a reaction with water. So of what? NH4 plus a water molecule. That is hydrolysis. Right? Now the reaction needs to be reversible. So now, because of NH4 plus is positive, it is going to donate the hydrogen atom so that we can have our hydronium ion. Then it will be left with NH3. Okay, so this reaction will be called the hydrolysis. Now, let us check if it's balanced. 1, 4 plus 2, which is 6. 3 plus 3, which is 6. Okay. And
do I have to put it in that order?
What?
Do I have to put it in that order? What if I switch the hydronium in the NH3?
Oh, what if this comes there, this comes there?
Yes.
It doesn't matter, it's fine.
Okay.
It's fine. We are only interested if this is present, and they are both on the left. Okay. This is present and this is present and they are both on the right. The order, don't worry about it.
Okay.
Okay. Now, 7.2.2. 7.2.2. Write down the balanced equation for the hydrolysis of NH4 plus ions. What? This is what I did, Mas. Oh, this is
it's 7.2. Yeah.
Okay, yeah, of course. Well, I saw that I did that. Okay. Will the resultant solution from question 7.2.2 be acidic, basic, or neutral? Let me see. Where's my reaction now? See, now they're becoming tricky. They want me to judge my own reaction.
Q, so
Oh, okay.
it's
It's
actually
good.
wrong.
Then this one is also wrong.
Q?
Now, it is going to be acidic
Yes.
because of we see the presence of this
Mm.
and not OH. All right, so it is going to be
Yes.
acidic.
Acidic. And then if it were to be neutral, it wouldn't have any, or would it have both?
Yeah, yes, yes, it's gonna be neutral. No, oh, they said the reasons. Okay, so now the reason, because is because hydronium ions are formed in the reaction. Okay, yeah, enough about 7.2.3, 7.3.1. Okay, now sodium hydroxide solution is prepared. Now that is the real questions they are coming. 7 marks. Sodium hydroxide solution is prepared by dissolving 4 grams of sodium hydroxide in water to make a 500 cubic centimeter solution. 7.3.1. Calculate the concentration of the sodium hydroxide solution. All right, let's see. So 7.3.1. So the one concentration. So concentration equals to iso or mass in grams, mass divided by molar mass times the volume. Okay. Now we need to substitute. I'll go up and check some of the values that I have. The mass is 4 for 4 grams, and then molar mass of sodium hydroxide. Sodium is Na, ne?
Yes.
Eh,
So 23 plus 1.
So sodium hydroxide is NaOH, right? So according to the periodic table, let me check first.
Yeah, it's gonna be
According to the
2.
periodic table, it's 23 for sodium.
Mm-hmm.
Its oxygen is 16 plus 1 hydrogen, so it's gonna be 40.
Yes.
Right, so it's 23, 16, and 1, which is 40. So therefore, this is going to be 4 over 40 times the volume. So
Yes.
500 cubic something. So cubic centimeters. So it's 0.5 cubic decimeters because we need to write it in SI units.
Okay.
Okay. So which is equals to so I get 0.2 mole cubic decimeters.
Yes, I got the same.
Okay. Now that was the easy one, of course. Now, 7.3.2. During a titration, where's my pen now? During a titration, 12.5 cubic centimeters of sodium hydroxide solution neutralizes 25 cubic centimeters. So both these two values are volumes. Because of we've got two volumes, I'm thinking of the Savannah solution. Savannah.
Oh,
C B V. You remember, you know that kind of solution equation, eh?
yes, I know.
What are you thinking, you now? Hey,
No,
when you get me arrested, you see when
no. That's why when you said Savannah solution, I was like, what? I've never. And then,
you get me arrested. Now I'm teaching physics here.
I
Okay.
won't forget it now. I'm saying I won't forget the solution
Yeah, don't forget it.
now.
Yes. Now, sodium hydroxide solution neutralizes the 25 cubic centimeters of sulfuric acid solution accordingly, very important, to the following balanced chemical equation. So 2 moles, that's how you write this. 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid, which gives us 1 mole of sodium sulfate plus water. So this is a base, strong base, plus strong acid, which gives us a salt plus water. Okay. Now calculate the pH. Calculate the pH of the H2SO4 solution. One question, calculate the pH. So let me create its own page so that maybe I will write it on one page. Okay, now 7.3.2, the equation that I was talking about, Savannah divided by CP VP over LP. You have it somewhere in your formula sheet, right?
Yes.
So now I remember they gave us the 2 volumes. So here there is no need for us to, if both volumes they are given in the same unit, even if it's not SI units, no need for you to change because they will cancel each other, the units.
Okay.
So now concentration of the acid Ca, I didn't see it anywhere. It was not given to us. Right, it was not given to us at any given point. Okay. And what else? But concentration of the base, we calculated for it in the previous question here. Can you see it?
Yes.
Okay. So therefore we go down and substitute concentration. So where there is Ca, we leave it as Ca. Then where there is Cb, we give it a value 0.2. Now volumes. Both volumes. This is the volume 12.5. This is a volume of sodium hydroxide, the base. Then 25, it is the volume of what? The acid, right? So we go down there. On volume of the acid, we put 25. On the volume of the base, we put 12,5. Now equals to Na divided by Nb. These are number of moles. These are number of moles based on the balanced equation. Right? So, therefore, the ratio of acid is to the base according to the balanced equation is acid is 1, base is 2. Acid is 1, you see it here, acid is 1, base is 2. Acid is 1, base is 2. Therefore, you go down and put 1 on the acid and 2 on the base. So there is only one unknown, which is concentration of the acid. For it. Then you solve for it. So I'm going to be left with 25 Ca equals to 0.2 times 4.5 divided by 2. Let us press the calculator. I've got 1.25 divided by 25. Ca equals to. So for some reason I got 0.05.
Yes.
Mole per cubic decimeters. Okay. Now the question wanted the pH, right? Now we have the concentration of the acid. So because of we have concentration, then we can make use of this. So now, according to the balanced equation, how many moles do we have of the H3O plus? I mean, sorry. Let me go back to the equation. I know which equation now we're talking about. Yeah. Now, according to this balanced equation, right? So we want to know that does the concentration of the acid mean the concentration of the H plus or H3O plus, right? So have you ever heard of something called a diprotic acid?
Diprotic, yes. I've heard of it, I don't remember, but I remember it well.
That is an acid that can or recompose, that can donate 2 nitrogen protons. That is diprotic acid, right? So the acid that you're dealing with, it's diprotic. So because the concentration of the acid is 0.05, that means that the concentration of the H plus, it is twice the amount because it is a diprotic. It's gonna be 2 times 0.05, which is 0.1. Do you understand what I'm trying to say here?
Almost.
Okay, I will repeat.
Okay.
A diprotic acid in a solution, it donates 2 hydrogen atoms. Right? So, because we got the concentration of the acid, so the concentration of the acid is 0.05.
Yes.
But the concentration of H plus ions, which are the ones that we define an acid with, must be double the ones of an acid. Why? Because every acid donates 2 of the H plus ions.
Okay.
Okay.
So how can you tell? How can you tell if it's a diprotect? Yeah, this one. If it's that acid, we have to multiply by 2.
Come
How do
again?
I? How do I tell if it's a diprotic acid? How do I
Because
know?
it has 2 hydrogen atoms. If it is monoprotic, it is like
Oh,
hydrochloric acid. Hydrochloric acid, it is monoprotic because it only has 1 H. Some of them, they are not diprotic, they have 3, like phosphoric acid. Phosphoric acid is H3PO4. So that one
okay,
needs 3.
okay, okay. Now I understand.
Okay. Okay, do you understand the logic now?
Yes, I understand the logic.
Okay. So therefore, with the same logic, yeah, that I said there. Let's go back to where I calculate. So now I will say, why is it vice versa? Concentration of H3O plus equals to 2 times the concentration of H2O, H2SO4, which is equals to 2 into 0.05, which is equals to 0.1. Now that is the concentration of hydronium ions. Therefore, pH equals to minus log the concentration of hydronium ions. Okay, then we can therefore say minus log the concentration of that,
0.
which is 0.1. Yes. Then we press it. So here's my calculator.
I got 1.
We got 1. Okay, that means your pH is 1. pH doesn't have units. Okay. So let me see now.
So that's the final answer.
Yes, yes.
So
Because
where would I get my marks here? 7 marks. Where?
you're planning on jumping steps.
No, just to make sure I know, like.
Okay. Definitely, for writing the correct formula, there's always a mark, right? There's a mark for formula, there's a mark for substitution. So for correct substitutions on the left and on the right, they will mark you there. Sometimes they mark everything acid and everything base. But for the correct substitution, so before you even go down, you can have half the marks with the first 2 steps. Then when going down, that's where the trick goes. They reward you for proper. Now, this step of a diprotic acid as a whole has 1 mark. So the step has 1 mark. We don't know which one, so I wrote all of them, but only need 2 out of these 3. Right? So we've got 4, right? Now, for writing the correct formula here, it's a mark, correct substitution here, and a final answer.
Okay.
So the concept that they are testing you, number one, balancing.
Yeah.
They're testing your stoichiometry skills, and yeah, you just know, just be able to know how to manipulate equations. You're gonna be fine.
Mm.
So no knowledge is useless. In this topic, they test you. Trust me. Who would think about a diprotic acid? So you must know, make sure that your theory is on point.
Yeah.
Now let us get another question here for you. No, my class never goes off without very beautiful homework. Let me see. Because the first time we did work, ne?
Yes.
Okay. Uh, um, okay, it's the question. It's page 9 and page 12. Okay, print page 9 and 12. Page 9 and page 12. Okay. Now for, oops. Oh, here we have the formula sheet I thought we would need. I didn't even use it. Oh, like me. And import. Okay. I'm trying to give you some good practice questions. So this is for work, all right? This is for work, and okay, that is electricity. It's fine. Now let me import the chemistry one. Is it on page? This one you will Gmail a little bit. But it's a good exercise. Especially right. So, partly seed. Okay, don't worry. They're good for practice, man.
Okay.
If you can do this once, then you know you're good to go. This is the one for acid, the one for acid. Then this is for electricity. This is for work. Okay. So
Okay.
now I'm just going to allow this moment for you to ask me questions.